Alright, let's go. Number 10. The Great Attractor. In 1973, astronomers noticed something strange while mapping the motion of galaxies near the Milky Way. Our entire galaxy, along with thousands of others, was being pulled toward a specific point in space at 600 kilometers per second. Not drifting, not coasting, being dragged by something massive enough to move trillions of stars against the expansion of the universe itself. The problem is that we cannot see what's pulling us. The object lies roughly 250 million light-years away in the direction of the constellation Centaurus, hidden behind what astronomers call the zone of avoidance, a region where the dust and stars of our own Milky Way block our view of the distant cosmos. We know it's there only because of its gravitational signature. Everything in our corner of the universe is falling toward it. For decades, scientists assumed the Great Attractor was a supermassive cluster of galaxies, perhaps a structure 10,000 times the mass of the Milky Way. But when X-ray telescopes finally peered through the dust in the 1990s, the mass they found wasn't enough. The galaxies visible in that region could only account for a fraction of the gravitational pull being exerted on us. Something else was doing the pulling, and we could not identify it. Later observations revealed an even stranger truth. The Great Attractor itself is being pulled toward something larger, a structure called the Shapley supercluster, located 650 million light-years away. And that supercluster appears to be drifting towards something larger still. The chain of gravitational influence extends into regions of space we have never mapped. What makes this phenomenon particularly unsettling is what it implies. Our entire galaxy, every star you have ever seen, every planet, every form of life on Earth, is hurtling through space toward a destination we cannot identify, pulled by forces we cannot measure, for reasons we cannot explain. We are not stationary observers of the cosmos. We are passengers on a vessel being drawn toward something unknown, and we have no way to change this course. Number 9. The Hubble tension. In 1929, astronomer Edwin Hubble made one of the most important discoveries in science. The universe is expanding, and distant galaxies are moving away from us at speeds proportional to their distance. The rate of this expansion, called the Hubble constant, became one of the most critical numbers in cosmology. Everything we understand about the age, size, and fate of the universe depends on measuring it accurately. But here is where reality breaks down. We have two methods for measuring the Hubble constant, and they give us two different answers. The first method uses the cosmic microwave background, the ancient light left over from the Big Bang 13.8 billion years ago. By analyzing this radiation, cosmologists calculate the universe should be expanding at roughly 67 kilometers per second per megaparsec. The second method measures the distances to nearby supernovae and Cepheid variable stars. It gives a value of approximately 73 kilometers per second per megaparsec. The difference seems small, but the implications are catastrophic for our understanding of physics. One of these measurements is wrong, or both are correct and our model of the universe is fundamentally incomplete. The universe cannot be expanding at two different rates. Something about the distances we are measuring, or the physics governing those distances, contains an error we have not been able to find. For over a decade, scientists have refined both methods, using more powerful telescopes, better data, improved calculations. The discrepancy has not disappeared. It has grown. The gap between the two values is now too large to be explained by measurement error alone, and the statistical probability that both are correct within our current physics is less than 1 in a million. The truly disturbing aspect of this tension is what it suggests. If our measurements are accurate, then something exists in the universe that we have not accounted for. A force, a field, a form of matter or energy that distorts distance itself over cosmic scales. Every star map we have drawn, every galactic distance we have calculated, every prediction about the fate of the cosmos may be subtly wrong, corrupted by physics we have not yet discovered. Number 8. The Boötes void. In 1981, astronomer Robert Kirshner and his team were conducting a redshift survey of galaxies when they discovered something that should not exist. In the direction of the constellation Boötes, they found an enormous region of space almost entirely empty of galaxies. The void measures approximately 330 million light-years across, making it one of the largest known structures of its kind in the observable universe. To understand the scale of this emptiness, consider that a typical region of space this size should contain roughly 2,000 galaxies. The Boötes void contains only about 60. If the Milky Way were located at the center of this void, we would not have discovered other galaxies existed until the 1960s. The nearest galaxy to our own would be so distant that the light from it would take millions of years longer to reach us than it does in our current position. What makes the Boötes void particularly unsettling is that current cosmological models cannot fully explain how it formed. The universe is only 13.8 billion years old. Creating a void this large through normal gravitational processes, the slow migration of matter from low-density regions to higher-density regions, should take far longer than the universe has existed. The math does not add up. Astronomer Greg Aldering once described the discovery with stark clarity. If the Boötes void had been the location of our Milky Way, humanity would have believed itself to be alone in the cosmos for the entire history of civilization. The nearest neighboring galaxies would be so far away that even our most powerful telescopes might have missed them. Some theorists have proposed that voids this large could be evidence of collisions between parallel universes in a multiverse, the impact regions where two cosmic bubbles briefly touched and carved out regions of our reality. Others suggest they might be evidence of ancient cosmic strings, theoretical defects in space-time left over from the earliest moments after the Big Bang. We do not know. The Boötes void sits in the sky, 700 million light-years away, defying explanation, a hole in the universe we cannot account for. Number 7. Hoag's object. In 1950, astronomer Arthur Hoag discovered something that looked like an optical illusion. 600 million light-years away in the constellation Serpens, he found a galaxy that consisted of a perfect ring of young blue stars surrounding an isolated core of older yellow stars. Between the ring and the core lies a gap of empty space, dark and seemingly lifeless. Nothing in our models of galactic formation predicts an object like this. Galaxies typically form as spirals, ellipses, or irregular shapes. Ring galaxies are rare, usually created when one galaxy passes directly through another. But Hoag's object shows no evidence of a collision. There is no second galaxy nearby, no tidal debris, no streams of displaced stars, no gravitational distortion suggesting a recent interaction. The ring simply exists, perfectly circular, perfectly centered, as if drawn by a compass. Even stranger, when astronomers photographed Hoag's object more carefully, they discovered another ring galaxy visible through the gap between the core and the outer ring, billions of light-years beyond it. A coincidence of alignment so precise that some researchers initially thought the image had been manipulated. The distance between the core and the outer ring is approximately 75,000 light-years. That gap should not be empty. Gravitational dynamics suggest that matter should fill the space between the core and the ring over cosmic time. But the gap persists, and astronomers cannot explain what is preventing the inward migration of stellar material. What makes Hoag's object particularly haunting is that out of the hundreds of billions of galaxies in the observable universe, only a handful resemble it. We do not know how it formed. We cannot recreate its structure in our simulations without invoking special conditions we have no evidence for. It sits in the cosmos like a piece of cosmic geometry that shouldn't exist, a perfect shape in a universe dominated by chaos, and its very existence suggests our understanding of how galaxies form contains fundamental gaps we have not yet identified. Number 6. The cold spot. In 2004, astronomers analyzing the cosmic microwave background made a discovery that has troubled cosmology ever since. In the direction of the constellation Eridanus, they found a region of the ancient background radiation that was significantly colder than it should be. The cold spot, as it came to be called, spans roughly 1.8 billion light-years across and has a temperature approximately 70 microkelvins lower than the surrounding regions. That temperature difference sounds trivial. It is not. The cosmic microwave background is the most uniform phenomenon in the universe, the thermal echo of the Big Bang smoothed out over billions of years. Random variations of a few microkelvins are normal. A deviation as large as the cold spot, across a region as vast as 1.8 billion light-years, should be statistically impossible within standard cosmological models. One proposed explanation is that the cold spot is a supervoid, an enormous region of low-density space that cooled the background radiation as it passed through. But surveys of the region have not found a void large enough to account for the temperature anomaly. Whatever caused the cold spot, conventional matter distribution is not enough to explain it. A more disturbing explanation has gained traction in some theoretical circles. The cold spot might be evidence of a collision with another universe. In certain multiverse models, our universe exists as one bubble among countless others in a higher dimensional space. If another bubble universe ever made contact with ours, the impact site would leave a permanent imprint on the cosmic microwave background, a bruise on the fabric of reality where our cosmos briefly touched another. The distance to the cold spot is approximately 3 billion light-years. That means the collision, if it occurred, happened roughly 10 billion years ago, shortly after the universe itself was born. We are looking at evidence of an event that predates Earth by billions of years, a potential scar from contact with a reality we have no way to verify exists. And if one collision left a mark, there may be others, regions of our universe still bearing imprints from encounters with cosmoses we can never reach. Number 5. The distance between galaxy filaments. When astronomers mapped the large-scale structure of the universe, they expected to find galaxies distributed relatively evenly. What they found was something completely different. The universe is organized into a vast web, with galaxies clustered along enormous filaments of matter stretching hundreds of millions of light-years, separated by equally enormous voids. The largest known filament, the Hercules Corona Borealis Great Wall, spans approximately 10 billion light-years from end to end. To put that distance in perspective, the observable universe is only about 93 billion light-years in diameter. This single structure occupies more than 10% of everything we can see. Current cosmological models say a structure this large should not exist. The universe is not old enough for gravity to have pulled matter into a filament of that scale. The Sloan Great Wall, discovered in 2003, measures roughly 1.4 billion light-years across. The Giant Arc, announced in 2021, spans 3.3 billion light-years. Each of these discoveries pushes the boundaries of what cosmologists call the cosmological principle, the assumption that the universe is uniform on large scales. If structures can exist at these distances, something about our models of cosmic evolution is wrong. The truly unsettling aspect is the regularity of the voids between filaments. The gaps are too consistent, too precisely sized, to be purely random. Some researchers have suggested the universe's structure resembles a network, as if the distribution of matter follows rules we have not yet decoded. Others have pointed out that the large-scale pattern of filaments bears a mathematical resemblance to biological neural networks, an observation that has led to speculation about whether the universe itself might be structured in ways that mirror information processing systems. We are not looking at galaxies floating in random positions. We are looking at a vast, organized architecture that stretches across the entire visible cosmos, and we have no complete explanation for how it formed, how it maintains its structure, Chikdai, or what it might ultimately represent. Number 4. The distance light hasn't crossed. The observable universe is approximately 93 billion light-years in diameter, but the universe itself is larger, far larger. Because space has been expanding since the Big Bang, regions of the cosmos are now so distant that the light they emit will never reach Earth. Ever. They exist beyond what cosmologists call the cosmological horizon, and they are permanently, absolutely unreachable. The size of the actual universe is unknown. Some estimates suggest it could be at least 250 times larger than the observable portion. Other models propose the universe might be infinite. What we can see is a tiny bubble within a vastly larger structure, and our perspective is limited not by the power of our telescopes, but by the fundamental speed limit of light itself. What makes this distance particularly disturbing is what it implies about knowledge. There are galaxies out there, perhaps trillions of them, perhaps civilizations, perhaps entire physical laws operating differently than our own, and we will never detect any of them. Not in 1,000 years, not in 1,000,000, not ever. The light from those regions was emitted billions of years ago, but can never catch up to our expanding reality. We are cut off from most of existence by geometry itself. The situation is growing worse. As the universe continues to expand, and as dark energy accelerates that expansion, the cosmological horizon is shrinking relative to the matter within it. Galaxies that are currently visible will eventually cross the horizon and vanish from view forever. Astronomer Lawrence Krauss has calculated that in roughly 150 billion years, intelligent observers on a planet in some distant galaxy will look up at the sky and see nothing beyond their own local group of stars. Every other galaxy in the universe will have receded beyond the horizon. They will have no evidence that the rest of the cosmos ever existed. We are living in a narrow window of cosmic history during which the universe's vastness is still partially visible. That window is closing, and somewhere far beyond it, in regions we cannot reach and cannot perceive, most of reality continues to exist, forever separated from us by a distance that cannot be crossed. Number 3. The Voyager anomaly. In 1977, NASA launched 2 spacecraft on a mission to study the outer planets of our solar system. Pilots on Voyager 1 and Voyager 2 were never meant to leave the Sun's gravitational influence. They were meant to survey Jupiter, Saturn, and beyond, then drift silently into the void. Instead, they have become the most distant human-made objects in existence, and they have been exhibiting behavior that scientists cannot fully explain. Both Voyager probes have been decelerating at a rate slightly higher than predicted. The anomalous deceleration is tiny, approximately 8.74 times 10 to the negative 10 meters per second squared, but it is consistent. Something is pulling on them or pushing on them in a way that our understanding of gravity does not account for. The same anomaly was detected in the Pioneer 10 and Pioneer 11 probes before communication with them was lost. For years, scientists proposed various explanations: negathermal radiation from the spacecraft themselves, unknown fuel leaks, gravitational effects from the Kuiper belt. Each explanation accounted for some of the deceleration, but never all of it. The anomaly persists across multiple probes, launched decades apart, traveling in different directions, suggesting the cause is not a flaw in any single spacecraft, but something external, something acting on any object that travels far enough from the Sun. Voyager 1 is now approximately 15 billion miles from Earth, officially in interstellar space. The signals it sends take over 22 hours to reach us, traveling at the speed of light, and as it continues outward, the anomalous force continues to act upon it, slowing it fractionally with each passing year. Some physicists have suggested the anomaly might be evidence of modified gravity, so a proposed revision to Newton's laws that would replace dark matter as an explanation for galactic rotation curves. Others have proposed that the anomaly indicates the influence of dark matter directly, exerting forces we cannot otherwise detect. A few have suggested something stranger, that the anomaly hints at the existence of structures beyond the solar system that we have not yet discovered, gravitational influences from objects or regions our telescopes cannot see. Two small machines, launched nearly half a century ago, are traveling into the dark, and something unknown is touching them. We do not know what it is. We only know that it is there. Number 2. The black hole violation. In 2017, astronomers discovered a quasar called J0313-1806 located approximately 13 billion light-years from Earth. The light we see from this object was emitted when the universe was only 670 million years old, a cosmic toddler by any measure. What makes this discovery profoundly disturbing is what lies at the quasar's heart, a supermassive black hole with a mass of approximately 1.6 billion times the mass of our Sun. That black hole should not exist. It is too large, too early, too close to the beginning of everything. Black holes grow by consuming matter, and the growth rate is limited by the Eddington limit, a physical constraint that prevents them from absorbing material faster than a certain speed. According to current theory, 670 million years is not enough time for a black hole to reach 1.6 billion solar masses through normal accretion. It would take billions of additional years. And yet there it is, fully formed, consuming matter, emitting light across 13 billion light-years of cosmic distance. Dozens of similar supermassive black holes have now been detected from the early universe, each one defying the timeline our models predict. Several explanations have been proposed. Perhaps the first stars were hundreds of times more massive than any we see today, and their collapse produced enormous seed black holes. Perhaps the early universe contained regions of matter so dense they collapsed directly into black holes without passing through the stellar phase. Perhaps black holes can grow faster than the Eddington limit under conditions we do not yet understand. None of these explanations are confirmed. The supermassive black holes in the early universe remain an unsolved problem, and each new detection deepens the mystery. We are looking across 13 billion light-years of space, and seeing objects that, according to the laws of physics as we understand them, should not be there. Either our timeline of cosmic evolution is wrong, or something we do not recognize was creating massive gravitational objects in the first 100 million years of existence, building the skeleton of the universe with mechanisms that remain invisible to us. Number 1. The Great Silence. In 1950, physicist Enrico Fermi asked the question that still haunts astronomy. Given the vast age of the universe, the billions of stars in our galaxy alone, and the apparent ease with which life emerged on Earth, where is everybody? The galaxy should be teeming with civilizations. Instead, across every distance we have surveyed, we find nothing. The numbers are staggering. There are approximately 400 billion stars in the Milky Way. The galaxy is 13.6 billion years old. Even if intelligent life emerges only rarely, the time required to colonize the entire galaxy using conventional spacecraft traveling at a fraction of the speed of light is roughly 10 million years. That is less than 0.1% of the galaxy's age. If even one civilization had emerged a few million years before us, their presence should be unmistakable. Self-replicating probes should be in every solar system. Megastructures should dim the light of distant stars. Radio signals should flood the spectrum. We have looked. For over 60 years, astronomers have searched for any sign of intelligent life beyond Earth. They have scanned millions of star systems for radio emissions. She just analyzed the atmospheres of exoplanets for signs of industrial pollution, searched for infrared signatures of Dyson spheres. The result is an absolute unbroken silence. The distance between us and any other intelligence in the cosmos remains uncrossed, unconfirmed, potentially infinite. What makes this silence particularly unsettling is that it cannot be reconciled with statistics. The probability of Earth being the only planet with intelligent life in a galaxy of 400 billion stars is vanishingly small. Something is wrong. Either life is far rarer than we believe, or civilizations destroy themselves before they become detectable, or something actively prevents them from reaching the stars, or the intelligences out there are deliberately hiding from us, or they are here already and we cannot perceive them. Yet every possible explanation leads to a darker implication. If life is rare, we are cosmic accidents, alone in an empty universe. If civilizations self-destruct, our own future is already written. If something prevents expansion, a filter or a predator or a force we cannot imagine, it waits for us somewhere in the distance ahead. If they are hiding, they have reasons to hide. If they are here, they have reasons not to reveal themselves. The distance between us and the answer is vast. It may be measured in light years or in centuries of searching or in forms of knowledge we do not yet possess. But every night, when astronomers turn their telescopes toward the sky and listen, the silence continues. Somewhere out there, in the infinite dark, the answer exists. We just have not reached it yet. If you want to see more videos like this, click the video on screen now and make sure to subscribe.